So for us, we're going to come in and add the radical inside the radical first. So we have a -3 plus or minus. The 9 plus 28 is going to give me a 37 all over 2. And then if you can simplify the square root of 37, you would. But for us, 37 is prime. There's no way to break it down. So we end up with a -3 plus or minus the square root of 37 all over 2. And hopefully you remember the quadratic formula. We're going to need it occasionally, so that's why we had to go over it first. Comments or questions on using a quadratic formula? Sorry, there's a little bit of a glare from the camera itself, my laptop. Well, we're going to go ahead and start it on section 1.4. We'll start the section today in terms of lecture. We'll finish it tomorrow in terms of lecture. So section 1.4. I encourage you to go back and look at the other sections. When you buy access into MyLab Math, you get the e-text, and you can go back and look at all this, the previous sections if you want. So section 1.4, today we're going to work on solving radical equations. So these are equations that have radicals inside of them. It's just a good place to start. So what I want to do is solve the square root of 2x minus 1 is equal to 4. So I see a radical equal to a constant. That's a 4 sitting over there. The nice thing about algebra in my mind is that you can always, no matter what, usually write a set of steps that will help you figure out what's going on. So we're going to come in and start writing some steps over here on the side that we can follow as we do our homework. Okay, so the one thing you always want to do is make sure you isolate the radical. So you want to get the radical all by itself on one side and then set it equal on the other side to the constant. So in this case, that's already been done for us. We don't have to move anything. Okay, step 2, we're going to come in and raise both sides to the same power. So raise both sides the same power. And what that's going to do is it's going to eliminate the radical for us and get rid of that square root. So for us, because we have a square root, we'll come in and square both sides. So on the right side, 4 squared gives me 16. On the left side, that square root disappears and we just end up with 2x minus 1. So 2x minus 1 is equal to 16. Okay, now you don't have one of these, but I want to put a third step in. You may need to repeat steps 1 and 2 if you still have a radical. So on a couple of the homeworks tonight, there's going to be 2 radicals, and when you square them, you still have one of them left. So, but for us, we're going to solve from here. This is a linear equation. It's considered to be a linear equation because there's no exponents left in it. So we'll come in and move the 1. That's going to give me 2x is equal to 17, and then we'll divide both sides by 2. And we get x is equal to 17 over 2. And so that's our solution. However, because it's a radical, we have to make sure we don't end up with square roots of negative numbers. So our last step down here is we're going to come in and check the answer. And to do that, we'll take the 17/2 and put it back in up here. Usually you just need to do this verbally or mentally in your head. So if I take 2 times 17/2, the 2 and the halves will cancel. I get 17. That gives me 17 minus 1. Well, 17 minus 1 is 16, and the square root of 16, sure enough, is 4. So it checks. We get the right answer. We know that x is equal to 17/2. So, okay, anybody have any question or comment about that? Is the board coming out okay? I'm going to assume, yeah, we can see it okay. I was really worried about glare. Thank you for responding. It's nice to know I'm not just talking to my computer. So let's solve one that's a little bit more complicated then. So what if we have a cube root? So this is example 2. We're going to do the cubed root of the quantity 1 minus 2x minus 3 is equal to 0. So the cubed root of 1 minus 2x, all under the radical, minus 3 is equal to 0. So let's follow those same steps again. So the first step was to isolate the radical. Well, this time the radical and the constant are on the same side. So we're going to go ahead and move that 3 to the right side. That'll give me the cubed root of 1 minus 2x is equal to 3. Then we can go ahead and clear the radical by raising both sides to the same power. This time, however, because it's a cube root, we can go ahead and cube both sides. So that was step 2. When we cube the cube root, we'll end up with just the stuff that's under the radical. And on the other side, we'll end up with 3 cubed. Well, 3 times 3 times 3 gives us a 27. We don't need the third step because everything canceled in terms of the radicals. They're all gone. So we'll go ahead and move the 1 to the other side. It's going to give me a 26. And then we'll divide both sides by the negative 2. And I end up with a negative 13 as my solution. I need to check it. So before I call it good, we're going to plug that back into the original equation just to make sure everything is working. When we plug in the negative 13, we're going to end up with, so over here is my check. I have 1 minus 2 times that negative 13, and that's all underneath the cube root. Well, negative 2 times negative 13 gives me a positive 26. 1 plus 26 gives me a positive 27. And sure enough, the cube root of 27 is 3. So back in the beginning, 3 minus 3 would equal to 0. So that works too. Comments or questions about that one? What I have found when I use the whiteboard in a classroom is that I tend to write a little faster than normal. So if I'm going too fast, you guys need to flag me and say, nope, slow down a little bit. Okay? The whole idea here is that you're going to get your money's worth and get your lecture. So are we good?
Yes.
Thank you. Okay, let's get a little more complicated. So let's come in and solve the square root of x squared minus x minus 4. And that's going to be equal to x plus 2. So one of the reasons that this problem is different is all of a sudden we see an x outside of the radical, which didn't happen before. We also see an x squared sitting inside the radical, so that got us a little worried. However, the first step's already done. We have the radical equal to everything else. The radical is all by itself on the left side. So let's just go ahead and square both sides. We're back to doing a square, so we'll do a square to undo the square root. Left side's easy. The square is going to undo the radical, and we'll end up with x squared minus x minus 4. The right side is where if you make a mistake, you're probably going to make it. So what I'm going to do is write that x plus 2 out twice, because that's what that outside square means, and then we'll FOIL it out. The reason we have to use FOIL is all of a sudden we have 2 terms being multiplied by 2 terms, so that means FOIL. So the first term would be the x times the x. That's going to give me the x squared, and again, that's this x times this x. The outside term is x times 2, which is going to give me a plus 2x. The inside term would give me the same, another plus 2x. And then finally, that 2 times that 2, that would be the last term. 2 times 2 is going to give me a 4. So I end up with x squared plus 2x plus 2x plus 4. Let's collect like terms. That'll give me x squared plus 4x plus 4. And for the first time, we end up with a quadratic. And again, it's a quadratic because we see some x squared sitting here. However, when you go to solve quadratics, you always want to set them equal to 0. If I try and move these x squareds to one side, what's going to happen to them? They're going to cancel out. So those x squareds are gone. So we have negative x minus 4 equals 4x plus 4. That's a linear equation because those exponents have disappeared. At that point, we need to move all the x's to one side. You always want to move the smaller x. It's just an easier way to do things. So we'll move that x to this side. That'll give me a -4 equals 5x plus 4. And I move over here. I'm running out of board. I'll rewrite it. So -4 equals 5x plus 4. And then we'll move the 4. I'm going to get -8 is equal to 5x. And then finally divide both sides by 5. And you end up with a solution of -8/5. So now if I was going to check this one, I would do it using a decimal. So I would take the -8/5 to a decimal. That's -1.6. And then plug it back into the original equation to make sure -1.6 works. And it probably will. If I square it, it's going to be a positive. So I have a feeling it'll work. So let's do another one similar to that that has the foiling in it, because that's, if again, where you're going to make a mistake, it's going to happen. Any comments about that one?
X plus 2 squared, that can also just be seen as the sum of squares, correct?
Yes, it is the sum of squares, correct. Yep.
Okay.
Nice.
Can I see the bottom? What'd you get for the very bottom, the solution?
I got a -8/5. Sorry.
-8/5, okay.
Yeah. There. Does that appear down there?
Okay, yeah, we're good now. Thank you.
Okay. I need to try and maybe draw a line across the board where I can't write below it. Okay, let's do, like I said, another one that's similar to that. So we want to solve 3 plus the square root of 3x plus 1, and that's going to be equal to x. And again, I am just pulling these straight out of the textbook itself, so yours on the homework are very similar to it when I went through and picked them. So step 1 was to isolate the radical. So that's telling me that I need the radical by itself. So we're going to move this 3 to the right side. So we'll subtract 3 from both sides. So that's going to give me the square root of 3x plus 1 is equal to x minus 3. Now that the radical is by itself, we'll come in and square both sides. So square this side, and we'll square this side. So on the left side, I get 3x plus 1. On the right side, I'm going to write that out again as x minus 3 times x minus 3. That reminds me to do the squaring correctly. And in this case, that would be the difference of, not the difference of squares. Instead of the sum of two squares, I guess it would be the difference of squares. No, that's not the way to call that. Let's just FOIL it. So the first term, again, is x squared. The outside term would be x times the -3. That's a minus 3x. The inside term would be the -3 times the x, which gives me another minus 3x. The -3 times the -3 is going to give me a positive 9. Now we can collect like terms. And all we're doing basically is adding those two terms of -3x's together. So we have x squared minus 6x plus 9. This point, we definitely see that it's a different equation. We have an x squared, and it's not going to cancel out. So because this is a quadratic, so because of the x squared, this term right here, we need to move everything to one side and set it equal to 0. So we'll move the 3x over, and we'll move the 1 over. So we're going to get 0 equals x squared minus 9x plus 8, and that's equal to 0. Luckily for us, this one's going to factor, which makes it a quicker process than using the quadratic formula. You can also go to the quadratic formula. It takes longer. You're more likely to make mistakes, so I tend to factor because it's quicker. I need factors of 8 that are going to add to 9. So factors of 8 that add to 9 are 8 and 1. Because we're adding, they both take the first sign, we'll give them both a minus. So we end up with x minus 8 times x minus 1. And if you FOIL that out, you'll end up right back up here. And then we're going to set both of those factors equal to 0. So we set x minus 8 equal to 0. And we'll set x minus 1 equal to 0. So one factor gives us an answer of 8. The other factor gives us an answer of 1. So we get two answers here, both 8 and 1. Now, I'm always rather skeptic when I get two answers. So what we're going to do is plug them in one at a time to see if they work. So way back up at the beginning, it was 3 plus 3 times the 8. We'll use the 8 first. Well, 3 times 8 is 24. Plus 1 is 25. Square root of 25 is 5. So that would give me 3 plus 5, which equals 8. So the 8 works. It's a good answer. Let's check the 1. So 3 times 1 is 3 plus 1 is 4. Square root of 4 is 2. That gives me 3 plus 2 is equal to 1. That does not work. So for the first time, we've got an answer that doesn't work. So the 1 is an extraneous solution is what the book calls it. Extraneous, it's a big word. Simply means that it comes out of the solving process, but it doesn't work when you check it. So only the 8 works. I really like this problem. You're going to see something similar to this both on the homework tonight and also this week's quiz. So it's a good quiz question. So make sure you can work it. Any comments or questions about that one? It's probably the second longest problem you'll do tonight. Okay. No comments must mean a good sign. Okay, let's do one that has 2 radicals in it, just to show you that they can get a lot uglier, whether we want them to or not. Let's say we have the square root of 3x plus 1 minus the square root of x minus 1, and that's going to be equal to 2. So the square root of 3x plus 1 minus the square root of x minus 1 is equal to 2. So for the first time, we see 2 radicals. So let's follow the same set of directions, though. They say to go ahead and isolate one of the radicals. So that's telling me to move one of these to the other side. So I'm going to pick up this entire radical and move it to the right side. So that'll give me the square root of 3x plus 1. That's equal to 2 plus the square root of x minus 1. Notice that I did not change the sign inside the radical. Only the sign in front of the radical is the one that gets changed. Now we're going to go ahead and FOIL both sides. So we're going to square both sides. On the left side, that gives me 3x plus 1. On the right side, I'm going to write that out twice, just like I did on the previous 2 examples, because I'm going to have to FOIL. Okay, so when we FOIL, we'll go ahead and do the same thing we did twice before. We're going to do the first outside, inside last. So the 2 times the 2 gives us a 4. The 2 times the radical, well, I can't multiply those, so I'm just going to write it as 2 times the radical. So 2 times the square root of x minus 1. When I go to do the inside one, I'll get the same thing. That's 2 times the square root of x minus 1. That's this guy times this guy. Then finally, what happens when I multiply the radical by itself? Well, the radical is going to disappear, and we'll get just x minus 1. Let's collect like terms and see what's going on that right side. So you have a 4 at the very end is a minus 1, so 4 minus 1 gives me a 3. I have a plus x that was at the tail end, and then I have 4 times the square root of x minus 1. So I've simply added things that are like on that right side. Still equal to 3x plus 1. So in our initial set of steps, we had a step 3, and that step 3 was if you still have a radical, isolate and repeat steps 1 and 2. Well, we still have a radical. It's sitting right here. It's that square root of x minus 1. So what we're going to do is isolate that radical with the 4. We're going to move the x and the 3 to the other side. So we'll subtract the x, and we'll subtract the 3. That's going to give us 2x minus 2 equals 4 times the square root of x minus 1. And now we're kind of back to the ones we did at the beginning. So it is a very long problem. I would not put this on a quiz or an exam, only because it takes so long and it would eat up so much time, but it is a good homework question. We're going to square everything again. That's to clear out those the radicals. So on the left side, that's 2x minus 2 times 2x minus 2. When we FOIL, outside term will give us 4x squared. First term is 4x squared. The outside term is minus 4x. The inside term is minus 4x. The last term would give me a plus 4. Now on the right-hand side, it's important to recognize that because the 4 is next to the radical symbol, we don't need to FOIL. That's a times versus two separate terms. So 4 squared is 16 times the x minus 1. Okay, I'm getting kind of low on the board again, so I'm going to kind of squeeze in over here. Collecting like terms is 4x squared minus 8x plus 4. That's equal to, on the other side, I'll distribute into 16 and get 16x minus 16. So I've collected together the middle terms, and on the right side we distribute it. It's still a quadratic, so we have to set it equal to 0. So that means to bring over the 16x and the 16. So that's 4x squared minus 24x plus 20 is equal to 0. Whew. And we're still not done. What we are going to do before I try and factor this is recognize that the 4, the 24, and the 20 will all divide by 4. So to make it easier, we're just dividing everything by 4. You can do that because it's equal to 0. So that's going to give me x squared minus 6x plus 5 is equal to 0. And that then factors. And I'm low on the board again. So, boy, I really hate to do this. Guess I'm going to go up top. So I have x squared minus 6x plus 5 is equal to 0. And we need to factor that. So what we're looking for are factors of 5 that add to 6. So factors of 5 that add to 6 are what, 5 and 1? So x minus 5 and x minus 1 is equal to 0. So x equals 5 and x equals 1. So we get two solutions again. I'm skeptic. Usually only one of them or none of them work. So, and again, we're right up here. So let's see if both of these work or none of them work or one of them works. So I'm going to take the 5 and plug it back into the original equation. So I have 3 times 5, which is 15, plus 1 is 16. Square root of 16 is 4. So right now I have a 4 minus. 5 minus 1 is 4. Square root of 4 is 2. And 4 minus 2 is 2. So definitely works. So the 5 is good. So I'll put a little check mark underneath it. Let's go check the 1. See if the 1 works. Okay. 3 times 1 is 3, plus 1 is 4. Square root of 4 is 2. 1 minus 1 is 0, and square root of 0 is 0. So 2 minus 0 also equals 2. So they both work. Highly unusual, but sometimes that happens. So both answers do work. Again, that's as ugly as they're going to get. Those are the only ones you'll really struggle with. And I think you only have 1. Yeah, there's only 1 on the homework. So that's a nice thing to do. Okay, let's do one more and then call it good in terms of solving radicals. Well, I hope nobody had any questions. So I erase it. Okay, and the last one we want to solve, it's just written in a little bit different format, so I wanted to make sure you were familiar with it. So I have in parentheses 5x minus 2. I'm going to put that to a 1/3 power is equal to 2. And the directions are just going to ask you to solve. If you look at that, say, well, that doesn't look anything at all like the other ones we've been doing. But just a reminder that, and this is especially for those of you that are in the biology world, if you're headed into the applied calculus course after this one, you'll see a lot of fractional exponents. That a fractional exponent is the same thing as a radical. So if you have x to the 1/n power, then that's really the nth root of x. So that simply means that I can translate this problem into a cubed root instead of a 1/3. So this means a cubed root. And then we're back doing what we did with the other examples. So let's go ahead and cube both sides. Since the radical is already by itself, we can go in and cube both sides. On the left side, we get 5x minus 2. 2 cubed is 8. 2 times 2 times 2. Solving for the x, and again, because it's linear, meaning no exponents, we don't have to set it equal to 0. We'll just move the 2 over. We'll get 5x equals 10, and then we'll divide by 5. So x is equal to 2. So we get a solution. It was nice and quick, in fact, after the last one that was kind of long. Let's plug the 2 back in. 5 times 2 is 10. 10 minus 2 is 8, and the cubed root of 8 is 2. So it does work as a solution. So it's a good answer. Okay, so when you take a look at your online homework, what you're going to see is a section 1.4 day 1 and a section 1.4 day 2. So what we just did was the lecture that goes with the day 1 material. We'll come back and do the day 2 material tomorrow. And I think that's all I have to say. Does anybody have any questions? And did everybody get their survey filled out so we can figure out whether or not what the best time is to meet as a class? So you need to unmute and let me know what's going on in your world.
Yeah, my survey was complete.
Okay. So I will pull that together tonight. Let's see. Who would I not talk to? Sydney, I know you got it completed. Christina, you did the survey, right?
Yes.
Okay. Mark, did you get the survey done for the class times?
Yes, I got it complete, ma'am.
Okay, and Jose?
I got it complete.
Okay, and Matt?
Not yet. Some
Okay.
life came into affect that, but I'll
I
get it
do
done today.
understand that. Yeah, try and get it done today. For now, let's go ahead and tentatively, I'll send out a Zoom meeting for this time tomorrow also. And then by Wednesday, maybe we'll get the class moved to whatever time works best for everybody. But for tomorrow, we'll go ahead and meet at the 1:15 time slot again too. Does anybody have any other questions or comments for me? Anything else I need to address that I did not address or I covered too quickly because I tend to talk fast when I'm nervous? Nobody? Okay, well, I'm good to go if you're good to go. I did record this. I just need to figure out where I'm supposed to put it. I think they're going to try and attach it to the class. I don't honestly know where it goes from here, but that way if you miss a session, you can still go back and take a look at it. But I did take attendance. I have a little post-it with everybody's name on it, so I will be taking attendance. That way I know that people are participating. Anybody else? Okay, well, if you're good, I'll stick on for a few more minutes, but if you've understood the lecture and you are clear on what you need to do for homework by Wednesday, then go ahead and end your meeting and log out, and I'll see you tomorrow, okay? Have a great afternoon. Enjoy it.
You too. Thank you.
Bye-bye.
All right. So I guess maybe just a follow-up question. So would you like, with your Pearson rep, I can get the ISBN off of the book that I ordered off of Amazon and then coordinate with the ISBN for the book that was specified for the course and see if they are going to
Okay.
compare? Would that help? Or
Yeah, so why don't you email me what you've got, and what I'll do is I'll just forward it on to my Pearson rep, and then
Okay.
she's been really good about getting back to me almost immediately, so she should then respond to you about what you need to do, okay?
okay, perfect.
That'll work.
Okay, so I do have a question for you.
Yes.
So I guess not recently. I got a job that runs from 6 o'clock to 2:30.
Oh, so you can't,
Yeah.
Ooh, every day of the week or what?
Every day except the weekend, pretty much.
Wow, well, good for you, because finding a job right now, I imagine, is not an easy task.
Yeah.
Wow. Okay, so you wouldn't be able to meet the class time no matter when I move it to.
Yeah, which is kind of what I was gonna either email you or just ask you about
Okay.
if there is a way we could work around that.
Yeah,
Or
I have no problem with it because the university is considering this to be a true remote class. I
Okay.
just feel that the people who registered early deserve the lecture. So
Yeah.
I will be trying to figure out how to get the lecture loaded onto either Blackboard to accompany the course or onto a YouTube channel, because I have a YouTube channel I used in the spring for just
Okay.
this reason. So you flagged me. Do me a favor, send me an email so that I have it in writing that you're not going to be able to attend the lecture because of a job, and it's
Okay.
not a big deal.
Okay.
And then My cell number is also on the Blackboard underneath the instructor information, as is my email. And if you need to get a
Okay.
hold of me, please do not hesitate to text me, okay?
Okay.
Because honestly, after the class is over, I'm probably not going to log back in for the rest until tomorrow morning. So
Yeah.
that'll work. You should be able to do everything. And then you can just work on the class in the afternoon when you're done with classes or done with work, okay?
Cool. Thank you.
Okay, not a problem. It was nice seeing you today.
Yes. You too.
Okay.
Have a nice
bye.
night.